SIF Philomen Raj, MSc, MPhil PhD, retired head Department of Physics, Madras Christian College, Tambaram, Chennai. He is presently serving as a guest lecturer in Loyola College, Nungambakkam, Chennai. He has a teaching experience of 35 years in Madras Christian College for UG and PG students. His field of research is nuclear physics, and he's presented about 30 papers in symposia organized by Baba Atomic Research Center, Mumbai. He has guided 50 MPhil students and about 100 MSc students in their projects. He has authored practical physics books for MSc and BSc courses. He is presently engaged in writing a book on nuclear physics for Printers Hall, India.
Welcome to UGC lecture series in physics. Let us continue with the nuclear and particle physics. Last class we have been discussing about the nuclear Coulomb energy, and now we shall be discussing the theory of successive radioactive transformations. So, when you say radioactive transformation, what is transforming? A nucleus changes. For example, uranium will become thorium. So, the nuclear itself changes. And what are the types of decay? So, we have got alpha decay and beta decay. So, here we will be discussing about alpha decay, beta decay and the natural radioactive series. So, we have the series like A equal to 4n, A equal to 4n plus 1, A equal to 4n plus 2 and A equal to 4n plus 3. Now, the theory of successive radioactive transformation. When you say successive, one after the other we get. Nuclear decay, what is nuclear decay? It is only disintegration. One nucleus is emitting some particle and therefore it disintegrates. Uranium, for example, it will emit one alpha particle and it will become thorium. So, that is a disintegration of a nucleus. So, naturally occurring, what is the type of disintegration occurring naturally? So, the natural radioactivity includes alpha decay, beta decay and also gamma decay. And this is even in schools we have studied alpha, beta, gamma radiation. But here in recent experimental techniques, they found that not only alpha, beta, gamma, there is some other particle also emitted. Namely, we get carbon 612 spontaneously emitted from a heavy nucleus, and we have O816 oxygen, isotope of oxygen, O816 emitted spontaneously. We have got neon 1024 also emitted spontaneously. So, these are called exotic decay because it is something different, exotic decay, and the general word can be cluster radioactivity. Alpha is also a cluster, and any cluster, any emission beyond heavier than alpha, we generally call it as cluster radioactivity. Now, this cluster radioactivity should have been in nature long before, from the beginning of the earth, but because of the technology, improved technology in experimental methods, now they are able to find out. Now, in the sense not very recently, maybe 20 years back. So, this cluster radioactivity have been established, and here the probability is very small. Maybe when you get 1000 alpha particle emitted, maybe 1 or 2 this cluster comes out. Therefore, the decay probability is small. Therefore, we will limit our discussion with what is very prominent like alpha, beta and gamma. And when you let us go to alpha decay, alpha is nucleus of helium atom, helium 24. It has got 2 proton, 2 neutron. So, 2 proton and 2 neutron together make up the alpha particle. It is the nucleus of the, because we do not include the electron here, it is the nucleus of the helium atom. And this alpha particle is very stable because it has got 2 protons which are coupled antiparallelly, and we have got 2 neutrons which are coupled antiparallelly. Say when you say antiparallel coupling, it is like from Pauli principle, if one proton takes plus half spin, the other proton will take minus half. Therefore, they will be attracted and coupled. So, that is anti-parallel coupling, strong coupling. Similarly, the 2 neutrons will take plus half and minus half and have strong coupling. As a result, alpha particle is a strong entity, it is a stable entity. Therefore, that stable entity comes out from a nucleus, that is a cluster. So, here we call it as alpha cluster. So, uranium 92-238 is the parent. So, that emits one alpha particle. So, what happens? It becomes thorium, because one alpha particle has come out. What is left is thorium 90-234, and this Q is the energy release. So, during this, energy will be released. Why is this energy released? Because this uranium has got less binding energy than thorium. So, the difference in binding energy will be liberated as energy Q. That Q will be carried by as kinetic energy of the alpha particle which is emitted. And of course, we will have a recoil of this daughter also, but the recoil of the daughter will be very small compared to the kinetic energy carried by alpha particle. So, this Q value is nothing but the difference in binding energy between the parent and daughter, which is coming as energy carried by the alpha particle. So, here in this reaction, in general, for alpha decay, the mass number A will become A minus 4, and the atomic number Z will become Z minus 2. So, that is what you see. See, uranium 238 has become uranium 234. So, there is change in 4. Similarly, uranium atomic number 92 has become 90. So, in general, we write as A will become A minus 4 and Z will become Z minus 2 for alpha decay. Therefore, instead of writing uranium thorium, we can generally write some nucleus X A Z. A is the atomic number, A is the mass number, and Z is the atomic number, and we get Y, that is the daughter nucleus, with the mass number A minus 4 and atomic number Z minus 2, and the alpha particle comes out. So, in general, we can write parent will become daughter and one alpha particle. So, this is the general idea about the alpha decay, and later on we will be coming to theory. What is the half life of this emission? That comes under Gamow theory. That will be in the next unit. Now, we will go to the other type of decay. So, already we stated that decay can be alpha, beta and gamma. Now, when you say beta, beta is a general term. It can be beta plus or beta minus. What is beta plus? Beta plus is positron, that is E plus. It is just exactly like electron with the mass of electron, but the charge is positive. And beta minus is electron, it is electron. So, it has got a mass of electron and the charge of electron, that is beta particle, that is the electron. Now, when you say beta minus particle, it is only the electron which is originating from within the nucleus, coming out from within the nucleus. And when it is an electron coming out from one of the atomic shells, we call it as electron. But when it is coming from within the nucleus, the same particle, when it is coming from within the nucleus, we have to differentiate. So, we just say beta minus, and the same particle the electron when it is coming from a cathode, from a filament getting heated, and there is a anode with a positive potential, these electrons will be attracted towards that. There the same particle we call it as cathode ray. So here when you say beta, it is from the origin is nucleus, within the nucleus. Now example will be zinc. Zinc has got atomic number 3065. So that will become copper 2965 by emission of beta plus and with some energy Q. Now here on the left side the charge is 30 because the atomic number decides the charge, and on the right side we get this 20, copper has got 29 charge and one beta plus is emitted, one charge is coming out. Because one charge comes out, 30 has become 29, one positive charge has come out, so 30 has become 29 and the energy Q. Here this not only this energy, along with this beta plus will have one particle neutrino, and here we are not just discussing about that neutrino. Under beta decay theory we will discuss about neutrino hypothesis, those things, but here we have just avoided writing neutrino because the discussion will be diverted towards the neutrino physics. Therefore we are just not included. Now the nickel 2865, that will also become copper 29 by emission of beta minus particle. So here again you see this is 28 has become 29 because one negative charge is removed. So removing a negative charge is equivalent to adding a positive charge. Therefore this 28 has become 29 because the minus charge has come out. Left side 28, right side you find that it is 29 minus 1, so 28. Here again we get Q value energy. Here we get beta minus, along with that there will be particle coming which we have not inserting here, that will be antineutrino. So in the first case along with the beta plus we get neutrino, along with beta minus we get antineutrino, and we need to discuss about neutrino separately, about hypothesis of neutrino and what is its charge, what is its spin, and whether it can be detected, and that is what we have got International Neutrino Observatory INO near Thieni, Madurai, near Madurai we have got, and its experiment is going on. So that will be a separate discussion and therefore we are not discussing here. So here during beta plus what we observe is 30 becomes 29 or Z becomes Z minus 1. Here for beta minus we get 28 becoming 29, which means Z becomes Z plus 1. Therefore in general we can write for beta plus A equal to constant. You just observe, see this zinc 65 has become copper 65, mass number has not changed, only the atomic number has changed. Therefore we can write for beta plus A equal to constant and Z becomes Z minus 1. Just check up whether we are writing it correctly. Similarly for beta minus, A equal to constant, again A equal to constant, say this 65, nickel 65, copper 65, and it is beta minus. So A equal to constant, and 28 has become 29. So Z becomes Z plus 1. So we get this. Now in general I can write, instead of writing zinc particular example, I can write general equation X A Z. So that is the parent, becomes Y, A is same, it becomes Z minus 1 plus beta plus particle. So the same thing we are writing as a general equation. Similarly for the beta minus, X A Z, Y A, and the atomic number becomes Z plus 1 plus beta minus. Now, in general, we can say the parent becomes a daughter plus beta plus or beta minus, one of the two. Now, when you say beta decay, it includes beta plus and also beta minus. And in addition to that, addition to this beta plus and beta minus, there is another phenomenon. It is called electron capture. Electron capture. Say, when does beta plus occur? When a nucleus has got excess proton. When a nucleus has got excess proton, excess charge. So, one charge is removed. So, beta plus emission occurs. Similarly, when there is a deficiency of proton, then a beta minus is emitted. Thereby, we will discuss this later on in beta decay again. In general, how do you get this beta plus and beta minus decay? It is a transformation of neutron to proton, proton to neutron. So, when a proton becomes a neutron, it emits beta plus, proton becomes neutron. So, it emits beta plus and the charge vanishes. Neutron becomes proton, then one charge is removed. So, we get beta plus or beta minus this. Now, there is another phenomenon called electron capture. So, when the proton number is large, then there is a proton excess in a nucleus, it wants to remove one charge, reduce one charge. It can reduce the charge by emission of beta plus. Sometimes beta plus emission will be hindered, will not be allowed. Why it not be allowed? Because the energy required will be at least that because it has got the rest mass, beta particle has got a rest mass, that energy is required. Now, when in that case the energy is not sufficient, but all the same it wants to reduce the charge. In that case, how it will reduce? It cannot emit beta plus, so it will pull one electron from the atomic shell. What is the closest shell? The K shell is the closest one. So, it will pull one electron from the atomic case. So, that is called electron capture, K electron capture. So, that electron capture EC, let me call it, put it as EC, electron capture will also bring this change. Z will become Z minus 1, Z will become Z minus 1. How it happens? Z becomes Z minus 1. One electron will enter the nucleus and it quenches the charge of one of the protons. Thereby, that proton will lose the charge and it will become neutron. That proton will become neutron. Thereby, the number of proton will reduce, and so Z becomes Z minus 1. Now, we will go to the gamma decay. So, already we stated the three types of decay process: alpha, beta and gamma. Now, we will just outline the gamma. Gamma is an electromagnetic photon. It is also an electromagnetic radiation. So, we know that electromagnetic radiation goes from radio waves, microwaves, and then infrared, then all that visible region, violet to WebGR, violet to red we have got, that is the visible region. Then on the other side we have got ultraviolet, then we have got X-rays, and then comes gamma ray. So, we get gamma ray in that region. So, the energy will be large. For X-ray it will be in keV and energy, keV energy. For the visible region the energy will be in EV. So, even in school you would have studied that for hydrogen the ionization potential of hydrogen will be 13.6 EV. So, that will be in EV, all the visible region will be in EV, and when you come to X-ray it will be in keV. Now when you come to gamma decay, it will be in MeV. So all the nuclear phenomenon will be in the energy of the order MeV. So we get X A Z. Here it's an electromagnetic photon. So we know that photon is like a light wave. It's only a light particle, photon. So it will not have mass and it will not have charge also. It has got only energy. It only carries the energy. So mass equal to 0, charge equal to 0, just like a light wave, light particle. Therefore we can just write, so A is not changing, Z is not changing, therefore the nucleus will not change. So XAZ will become XAZ. I will write a star. So the star indicates only the energy level changes. So the nucleus, there is no nuclear transformation, the nucleus remains the same. Maybe if it is original nucleus is maybe iodine, the daughter will also be iodine, but the energy will be different. The energy, it will be in excited state or in a de-excited state. So we get the energy difference alone will be there, because we have got the energy levels inside a nucleus. We have got energy level. Again this about the energy levels we will be discussing in shell model. When we deal with shell model, we can talk about the energy levels. It will be very similar to the energy levels in the atomic case. Atomic case we have got KLM shells. Similarly, within the nucleus we have got energy levels which are occupied by neutrons and proton. So and the energy level will be different, where star indicates excited energy level. Now here no nuclear transformation, already we discussed, only change in the energy level. So this is for the three types of decay. Now we will go to what is called radioactive series. There are 4 natural series: A equal to 4n, A equal to 4n plus 1, A equal to 4n plus 2 and A equal to 4n plus 3, where n is an integer. So you may just wonder what is this. Now in that series, for example, we have got uranium. Uranium will emit alpha particle, become thorium. Thorium again emits an alpha particle, becomes a daughter nucleus. That series goes on. So that is called natural series. That is what is happening in nature. If we take a radioactive rock, so you will find either all the elements. If you take a radioactive rock, maybe here and also from moon also, if you take a radioactive rock, it will contain elements with A equal to 4n, all of them A equal to 4n, or you take, or if it is having 4n plus 1, all of them will be having 4n plus 1. That is why we call the 4 type of series. And what is n? N is an integer. So here A equal to 4n. See, this one starts with thorium, thorium 23290, and it emits one alpha particle and it becomes Ra 88228. Say that mass number from 238 it has become 228, 90 has become 88. So that is alpha particle. This is parent, thorium is parent, Ra is daughter. Now this Ra emits beta minus particle. When it is emitting beta minus particle, mass number will not change. So 228 remains as 228, and because it is beta minus particle, removing a minus charge is equivalent to including a positive charge. So it will become 88, will become 89, and again this AC will become 228 thorium. So again we get this one thorium by beta minus emission, and again it emits alpha particle 228. So here if you go through the properties of elements, you will find the series. You have not put all the series together, I put just dotted lines, and the final will be 208, 82 lead. See, all these elements, thorium unstable, emitting alpha, Ra unstable, emitting beta. So everything is emitting something. It is, so it is not stable, unstable. Finally, when it comes to lead 82208, it becomes stable. It is not able to emit anything. That stops. Lead becomes very stable. it is neither emitting alpha, beta, gamma. So here, if you observe, I will just come back to this. Why we call it as 4n? See, we take thorium 232. So if you divide by 4, it is divisible by 4. If you take 232, divide by 4, we get an integer. There is no remainder. So it's divisible by 4. Similarly, 228 is divisible by 4. 228, 224, 208 is also divisible by 4. Therefore, all of them we call it as A can be written as A equal to 4n, where n is an integer. Like for 6, 7, 8, we can put any number integer, all of them will be falling in that category. So, the mass number A can be written as 4n, where n is an integer, or it will be multiples of 4. The mass number will be multiples of 4. When you come to lead, finally you will find that lead is stable, and you find that Z equal to 82 and N equal to 126. So, if you subtract 208 minus 82, I will be getting 126, that is neutron number. So, this is mass number 208 and the atomic number of proton is 82. So, 208 minus 82, I will be getting 126, N equal to 126. So, we call it as magic. When that number 82 comes, that element becomes stable, namely the lead. When it becomes 82, it becomes stable. It is emitting so many things, but when it comes to lead, it becomes stable, and N equal to 126, it is stable. Therefore, what we call this Z 82 and 126 are called magic numbers. See, earlier it was called magic numbers because they didn't, before the shell model came into picture, the scientists were not able to explain the stability of lead. Therefore, it was called magic number. Now, we shall just summarize what you have been discussing. So, we just studied about the radioactive transformation. So, in nature we have got only alpha, beta and gamma, and gamma is not giving transformation, and then we have got the series 4n, 4n plus 1. Now, we have just said about 4n. In the next session, we will be continuing with 4n plus 1 and 4n plus 2 and 4n plus 3 series. Now, we shall just have to refresh our mind, we will have some questions. Why is alpha particle very stable? So, already we discussed, it has got 2 proton, 2 neutron. Because of the antiparallel coupling, they are bound in a very stable manner. Why is beta decay termed isobaric transition? When you say isobaric, A is constant. Iso means same. Isobaric, you remember like this, we have got that A, mass number A will be constant. So, isobaric transition are transitions which have got mass number A is constant, and we just mentioned the 4 radioactive series in nature, and we just started with 4n. We will go to 4n plus 1, 4n plus 2, 4n plus 3, and we will conclude the session. And why 4n plus 1 radioactive series is missing in nature? Why? So, when we come to 4n plus 1, we will be discussing about that. Thank you.